Welcome to this EnergyVaasa Talks, today concentrating on gas. The future world will be electrified, but gases have a significant role in decarbonizing our world. We believe EnergyVaasa has the right solutions, whatever the challenges are. Today we will hear and see what's up in the EnergyVaasa Gas Exchange team. I'm Katja Jankens and I represent Nordic Hub, a network and platform for Nordic cooperation between companies and clusters. We bring clusters, companies and networks together, promote and develop cluster collaboration together with our Nordic partners.
And I'm Lasse, Pohjala, business advisor from VASEK and representing the EnergyVaasa team today. During this session, the chat on EnergyVaasa YouTube channel is open and ready for your questions and comment. Due to the limited time we have today, our team will answer the questions after this event, so stay tuned. We will start our webinar with Mr. Kenneth Widell, Senior Project Manager, Sustainable Fuels and Decarbonization, Wärtsilä, Finland. Kenneth will tell us about H-Flex E. So, nice to have you with us, Kenneth, and the stage is yours.
Thank you and good afternoon. So I'm here to tell you about a project that we are about to start called H-Flex E, and that abbreviation stands for Hydrogen Flexibility Electricity. And this is, to the best of our knowledge, the first industrial scale system where energy is converted into hydrogen, stored, and then reconverted into energy, electricity in this case, at a later convenience. And this project is driven by EPV, Vaasan Sähkö, Wärtsilä, and the city of Vaasa. And in this picture you see the main ingredients of that. We'll come back to that a little bit later. But it all boils down to transformation of green energy back into green energy, in a sense. So it's a storing solution where we can store energy when we have a surplus of it, and then reconvert it back when there is a shortage of that energy. Now, I said that this is something that we will start. We have put in an application to the Ministry of Economic Affairs and Employment. In Finnish it's called Suuret Demot. And when and if that comes true, then this is something that we will start hopefully very early next year. And the intention of which is to start this production early 24. But before we go into that, next slide please, a little bit looking into the potential that we see. You see here some statistics from Bloomberg, and that's the energy market trends predicted 18 to 30. This is from 2020, so it's a year old, but still we feel that it's somewhat valid, of course. And we can see in the top left corner that the amount of wind and solar power will grow 2-3 times from what it is today in the coming 10 years or so. All of the rest is either declining or staying stable, except for the flexibility. And here we can see on the bottom middle that batteries and peaker gas, so balancing systems, how to keep the grid afloat, I think is where there will be a huge increase. And you can see by the numbers that it's way bigger than the wind increase and solar on the energy markets. And that's of course due to the fact that when you increase the renewables, we need more flexibility. Next slide, please. And here, in brief, what this hydrogen flexibility electricity is all about. First of all, need to highlight that this is, of course, a true ecosystem joint venture, because this demonstration plant has a customer, EPV and Vaasa Gas, and technology provider, and also, of course, the local ecosystem. And here local means national, to bring solutions into this system. And all of these are willing to take a risk, because some of these do not exist today still, but we have a strong belief that we can and we will fulfill these expectations in due time. But what this all starts with, of course, as everything in the future, renewable electricity. In this case, wind power. And of course, we need water, clean water. That's for the next stage, where we then, of course, use electricity and by means of electrolysis water, and get hydrogen and, of course, oxygen, of course. And this we will all do when the electricity price is low, hence meaning where there is a surplus of wind power available. And in all of these different steps, and whatever energy conversion you use, there are always some losses. And here in this particular case, because this is intended to be placed in Vaasa, we have in the ecosystem a possibility to store all the excess heat, which is in a sense waste when we do this energy conversion, and that can be later then taken into use in the local district heating system, for example in the winter. Once we have had this hydrogen gas extracted from the water, and oxygen, by the way, that can also be used in the battery industry, which we will see in the near future in the region. And it's green oxygen, so that's also very positive. And we foresee that there will be a demand for that. What we will do, we will compress the hydrogen and be stored in gas form. And of course, a fairly high pressure will be used. And then at the, let's say, can be also daily cycles, but it can be weekly cycles as well, or even longer ones. We reconvert that hydrogen to electricity when, of course, the electricity price is high, when there is a shortage of electricity. So when the wind is not blowing, the sun is not shining, in a sense. Here, still taking into account what I said earlier, that we will start off by two existing gas engines, and we will put 25% of hydrogen from day one in terms of volume, and the rest can be then biomethane or LNG, depending on the availability of biofuels at that point in time. And the intention is to run this power plant at 100% hydrogen by 2026. And in the process, of course, we will store excess heat to the location which I mentioned. And the export potential here for the Finnish industry, and not only for Wärtsilä, of course, for the entire ecosystem, is of course the electrolyzer technology, hydrogen storage, and then also an extension, possibly, because all of these are scalable. If this is, or when this is rather a question of when this is fruitful, we can extend hydrogen production, and also through carbon capture, methanize this for electrical fuels, so-called e-fuels, may it then be synthetic methane or methanol, all green fuels. And they, of course, store longer and are easier to also, from a logistics perspective, to handle and move forward. Next slide, please. And the key takeaway of all this, of course, it's the first industry-scale hydrogen production storage electricity reconversion plant. Flexible green balancing, so no need of burning fossil fuels or any other kind of balancing technologies which are harmful for the environment. We have a huge potential global opportunity here. I mean, estimates say that 2,000 billion equipment only. And we have here the end-to-end solution. So we have a very modest estimate of this 2,000 billion. There is maybe 5 billion for the sort of ecosystem here nationally. And of course, it's greater for the early birds. And this is not only a demo plant. This will be in service for at least 40 plus years, producing green balancing energy. So what we want to show the world is, of course, that the energy transition that started yesterday, and it's worth to invest in this future-proof technology. And I think this is the point that needs to be highlighted. Many of our customers or players in the industry sector are contemplating which horse to bet on. And of course, they bet on a horse which they have seen running. So this is very important that we can demonstrate this in an industry scale to show that it's actually more than just a lab test. And of course, also the third part, which is equally important, and that's the transition. We will most likely not go from 100% fossil to 100% renewable overnight. We need a way to do this by introducing gradually these carbon neutral fuels without any risks. And this is a clear showcase thereof, because we can mix carbon neutral fuels with the fossil ones and then change that mix from 0 to 100 in a sense, depending on the cost and availability. And then, of course, without this funding that we have applied for, we will not, at least according to what we know now, be able to execute this. It will be postponed, and of course, then the competitive advantage will be lost. And next slide, please. So this is a way of securing the sustainable energy transition also for the balancing power needs of the world. Thank you very much.
Thank you, Kenneth. That was something really exciting. During your presentation, I made some notes, and I have a couple of questions for you concerning the VGE project. First, the energy transition will offer a lot of opportunities, even for small and middle-sized companies. If I would be interested in hydrogen business, should I concentrate on electrolyzers or methanation or something else? What would be your suggestion?
It's a very good question, Lasse. I'd say yes, there is a lot of business potential and there is a lot of players out there. So then looking into what would be your best capabilities and also securing a business case that you can survive. And we don't know how long this transition will take. As said, I don't believe it will happen overnight. So taking too big risks might be risky, but then again, we don't know. As if we go back 25 years ago with for example, wind power, that was all subsidized, and now it's, good business. I don't know if this will be similar. Probably not, but I do not believe that this will be, as said, fully up and running from tomorrow or next year. So I think that is the uncertainty, the timeline. So I would focus on going into projects where there is a secure business owner who is ready, willing to invest, and then work your way from there. And also join up with other players in the ecosystem.
Good advices. Thank you, Kenneth. And I have another question for you concerning the technology of the pilot plant. I saw that the pilot plant will be 24 megawatts. I assume the plant design is scalable. Kenneth, are there any restrictions for the minimum or maximum size of the plant?
Good one, Lasse. As such, I would say that no, they would fall in what in the similar size that we can deliver today. So from 10 to 200 plus megawatts. This is of course a very interesting business, again depending on where you are located in the world, as in some locations you can get really high price for the electricity when there is a huge shortage of it. So this depends then very much on what's sensible in which part of the world. So I'm sorry that it's difficult to say, but somewhere around those figures, yes. Thank you.
Okay, thank you very much, Katja. So we have to very closely follow the development of this HFlex E project, because it's a huge project for entire Vaasa region. That sounds like just perfect good news. Thank you, Kenneth.
Thank you very much.
And now we will continue with the role of gas in energy transition. And next up we have Tommy Mattila, Vice President, Industry Gasum. Welcome, Tommy.
Thank you very much, and thank you for this opportunity to come and talk a little bit about the role of the gas in the transition, and especially regarding the role of methane.
Yes, I'm glad to have you with us today. The stage is yours.
Thank you. Thank you. Good, let's take the next slide. So a little bit what Kenneth was touching upon as well, when we look at this carbon neutrality trilemma, I think it goes for all the sectors. Is it then households or heavy industry or marine or traffic? We have this huge pressure of reducing our CO2. And if we look there, the number one, how? So I think the first ones, the easy ones, let's say the energy savings part, has already been done in most of the industry, because of course that's the smart way to do, to first reduce the current use of your different energy forms, and thus also reduce your cost and reduce your emissions. Then it gets more tricky and tricky. The next one is that what kind of measures do you do then to really reduce your CO2? Do you do fuel changes? Do you do integrations? Do you do updates in your process, or what are those reductions means that you have? And for some industries might be that it's not possible to replace everything, at least on a short term, with renewable fuels, and thus you also need to have some compensation systems which are then valid. And the second one is of course a tricky part if we are looking that when to do. I think everybody agree that this probably needs to be done as soon as possible, and probably some already yesterday, to fight the climate crisis that we have ahead of us. But of course, from a certain industry perspective, if we have heavy industries which are, for example, competing in the global market, so when is the time to do it, to reach the targets? Do you be the forerunner, or do you wait for the others and come into the market later on? And of course, at what price? What is the price of the investments you need to do? What are the prices of the different fuels that you have to choose from? So as we are discussing, well, a lot of different customers in different segments, as I said, in the traffic segment, in the maritime segment, in the industry segments, these are really hard questions that the customers are today thinking about, that how do we solve this, and when do we do it, and what are the solutions, and what is the price of those solutions, and how does they then go into the global competition, for example, on the producing industry. Next slide, please. Then if we deep down a little bit, especially on what kind of role could gas have in this transition, and then especially talking about the methane molecule, and of course the methane natural gas consists of the methane molecule, and the beauty is of course that biogas also consists of the same methane molecule. And one other beauty is of course that the methane molecule as such can be used across the different businesses. There's a lot of discussion on EU being for some while already about the sector coupling or sector integration, and I think methane plays a very, very good role here in coupling together these different sectors, that we can use the same methane molecule. Is it then in cooking, heating, producing heat, producing power, firing your process, using it in traffic for heavy duty vehicles, passenger cars, or of course also in the maritime sectors for the shipping. And the good thing is of course that the current infrastructure can be utilized for the different way of producing this methane molecule in a more sustainable way. And the number one is of course the natural gas as such, and we all know that that's a fossil fuel, but I think it still have a role to play also to do something fast. I mean, in Finland and the Nordic countries, and I would say especially in Finland, we are still burning quite a lot of coal. We are burning a lot of peat. We are using a lot of oil, and I mean, just doing the from coal to natural gas, you will save 50% of the CO2, and also from oil to gas, you will do 25%. So I think it's important to do something today, and there also the fossil gas has a role to play. But that's of course not enough, and then of course it comes into play with the biogas, which is already a quite big product that Gasum is doing in the Nordic countries, and there's also operators in for example Vaasa Stormossen producing biogas, which is of course this beauty that you can have a circular economy, taking waste and making energy out of that, and having a sustainable energy, and again utilizing the same infrastructure that you do for the fossil gas, and completely blending them to whatever proportion you would like. So you don't have to go from 0 to 100% on the renewables, but you can make this smoother pathway depending on your own targets to reduce their CO2. And then of course then the next one is also then to use especially biomasses and having then so-called, I think it's a bad name, this synthetic natural gas, but what it's about is that having different biomass feeds, and then via this gasification process also again creating methane, and again utilizing the same infrastructure. And that is being done in Vaasa as well in the Vaskiluoto plant. And then of course the power to gas, which is a lot of discussed to make the by electrolysis from renewable power that you made hydrogen, but also you can continue that and taking that hydrogen and inserting CO2, so you get the methane, and again you can utilize the current infrastructure both for storage and for distribution compared to building a completely new infrastructure. So here we see a very strong role for the methane molecule to be part of this energy transition and make it a smooth transition, and still also then getting those targets to reduce the CO2 emissions in the different operations. Next, please. Then, of course, I think this is the tricky part, and just putting a little bit also on the time frame. And I think nobody has a real view on this, how this will go from a time perspective. But as I mentioned, there are still things that can be done also by replacing more polluting fuels with natural gas, which is a kind of easy low hanging fruit. But as I said, that's not enough, and then come into play different gases, the biogases, the circular economy cases where you use the waste come from to the power to gas, as was mentioned here as well, to come to the synthetic methane, and of course the hydrogen as such. And also we see in Gasum especially that this integration between different gases and the power is really the one which will help, because as Kenneth mentioned as well, we will see more fluctuation, for example, in power production, in wind power and solar power, and then gas has a role to play there, the different methane molecules, but they need to be more sustainable, of course, than the fossil gas. But this time scale is of course something which is the challenging part, what to do and when. But these bridges each other, I think, quite smoothly, and there's a lot of options that can be utilized, having gas and the methane molecule as a part of that portfolio. And we'll take the next please. And then touching a little, if that was a kind of a brief overview on the big picture and how the methane molecule can play a role and in the transition towards less carbon polluting future. It's also, of course, very nice to see things going on in Vaasa, and in fact Gasum is building this LNG intermediate terminal in Vaskiluoto, and in the first phase this will be serving Wärtsilä and then the new ferry, Vaasa Line new ferry. And I think this is also a good example of sector coupling, which is, as I said, a hot topic in EU, and this is really showing then that these are things being done in Finland already. We can utilize the same infrastructure for different sectors, both for industrial applications and for the maritime applications. And for sure, this strengthening the availability of the methane molecule within the Vaasa region. And again, this supply chain can also be utilized then for biogases produced in different sites around Finland, for example, and then brought to Vaasa and then helping on that way as well. And this is a project which is already ongoing. So it's probably a little bit small, the picture over there, but that will be the situation where the terminal will be located in the Vaskiloto near the oil terminal, which is there already. And we have done all the risk analysis. We have done all the basic engineering regarding the setup of the terminal, and we have chosen the main vendors for the equipment. And the foundation works is more or less to start as soon as possible, and then the foundation should be ready during the winter period, meaning that the main component being the storage tanks for the terminal would be arriving in Vaasa around April, and then it's the final commissioning and installation and startup of the whole package, and that should be ready then in May 2022. And take the next slide. So of course, as said, gas has a role to play in the transition, and at least from the gas perspective, we love gas.
Thank you, Tom, for your presentation. I have a few questions for you too. And it looks like we will have all the pieces available for an integrated and compact energy system in Vaasa. Will the LNG terminal be a part of the HFLEX-E solution?
It's a good question, and as we heard Kenneth's presentation, also the mention of methane LNG or LBG. So, of course, we haven't discussed the details yet, but at least from Gasum's side, we are very happy to look into that in more detail and see how we can utilize the current infrastructure which will be built in Vaasa. And I think that's gaining all partners, and again making this sector coupling and sector integration even stronger.
Thank you. And on one of your slides, I picked up GEOS. What is that? Could you tell us?
Yeah, for sure. There was quite many abbreviations in one of the slides, and GEOS is abbreviation for guarantees of origin. And this is more commonly already used in the power and the electricity business, meaning that if you also as a consumer, for example, buy wind power to your home, that's based on the guarantee of origin that somebody have produced that wind power and put it into the power system, so that's in balance. What's happening as well, and there's different certificate systems around the gas, and we are now seeing development also of guarantee of origin for gas and for the biogas, and that's very important. In that's how we see it, to really enhance also the biogas market and have clear rules on that, and that's in short guarantee of origin, that there's a guarantee that this biogas, for example, is produced in a sustainable way from waste and in a certain plant.
Okay, thank you for that, and thank you for being with us today.
Yes.
Thank you very much for this opportunity.
Thank you very much, Tom. That was something very, very interesting. And Tom already mentioned biogas and circular economy. And our next topic is biogas development and circular economy. And for that, we have here Mr. Aimo Latvala, Managing Director for Sturmossen, here with us today and tell more about biogas and circular economy. Nice to see you, Aimo, and welcome, and the stage is yours.
Yeah, thank you for the opportunity. Really nice to be here and hear all the interesting topics, and especially love to hear more about how everybody else is also finding methane a bit more. We can actually take the following slide and then look back a little bit. Next slide, and then have a look. Where have we started? Actually, Sturmossen was founded in 1985 and currently is owned by 6 municipalities. So we have, and in Finland we have 33 similar companies to Sturmossen. Biogas production started in 1990, and then it was actually the second digester in Europe. So we have more or less, we could say that we have quite a lot of knowledge within this sector. Heating of Botniahalli was at some point done with biogas, and actually the landfill gas collection that we started at 2007. So even that is now also taken care of. One big step towards, shall we say, improved carbon neutrality was the incineration plant of West Energy in 2012. Upgrading and filling station for biomethane was in 2017, and then we had a little bit to reinvent ourselves because we need to scale up all the shall we say how we recycle and the segregation of waste. And in 2019 we opened the first recycling mall in Finland, and actually the second in the Nordic countries. And then 2021 we started with a mobile recycling station working here in our area. And if you look at the figures, currently we have a recycling and plus digestion and segregation of materials. We are approximately at 34%. The energy recovery is 65%, and the landfill, there we are actually quite good. We have 1%, which is goes to classical landfills, which is of course very good because old landfill is actually very, very bad for the in order to or makes it really difficult to reach carbon neutrality. Next slide, please. Then if we look at the targets, what EU and Finland has committed themselves to, it's a 65% recycling of materials in 2035. We at Stormossen, of course, we have taken then a slightly more ambitious goal and in order to reach it already 2030. And when we start to look at how we are going to achieve it, we need to serve the society well in order to be able to collect all the waste. And of course, we can then provide some district heat back. But the segregation of waste at in the source point where the waste is created, we need to do, because we don't have, and there is not in the foreseeable future any method to do it on a good enough level. Then another storage topic, which is been touched already many times, I think will be the most interesting part from engineers' point of view, because energy storage, electricity storage area will have similar technologies, will also be used at Stormossen, but for slightly other purposes. But I think the Stormossen could also provide quite a lot of different new raw materials and also other opportunities to try new technologies, both for energy storage and also to how to treat digestates, which are currently slightly cumbersome to treat. Then we have industrial products, which will be, we have of course waste from industry, but then we also have new products like carbon dioxide, which actually also can be product at some stage, heat, steam, methane, methanol, ethanol, and different types of, shall we say, chemical products could be very useful for industrial purposes, but based on the new advances that we have made lately in the technological field. But the last but not the least is of course the agricultural part, where I think we could, due to the fact that we have an agricultural sector in Finland which is well developed, but I think it is far underutilized. Together with this energy transition and the waste management companies and agriculture, actually I think they all could be interconnected, because nitrogen and phosphor and carbon could be recycled to them, and in the same phase we could also use that for energy storage, and at the same time take care of different waste streams. So I think there could be a lot of possibilities. if we look, and then we could take the next slide and maybe look at it at a different way, because circular economy, of course, it's a circle, and when we have something that is supposed to work as circular economy does, it's up to all the segments or all the parts of the field or the area in order to get it to work. If some sector, like the transports, for instance, is not working correctly, then we will not have circular economy. It will maybe be economy, but not circular. So from that point of view, everybody's participation is extremely important. And of course, we will also have the legislation makers and other decision makers to make decisions that all supports also, like different sectors must be taken into account, because otherwise it might be that we make decisions that, and we have not considered, shall we say, the other sector, and that's why we fail. So it will be a very broad perspective that will be needed in order to achieve all the benefits that will be needed. And then we can take the next slide and look a bit at the carbon sink, because those will be needed if we want to achieve carbon neutrality. We will not get rid of all the CO2, and if we want to get carbon neutral, we must be able to create carbon sinks, which of course one example is the bio-waste. We have then the digestion process. There we have one side product is biogas, which we will use then for cars, etc. And the digestates are at some currently, at least to some degree, a small problem, but now we are looking into pyrolysis, which is also looked into, and together with electrolysis and other technological means how to treat these. And then we have HTC, which is hydrothermal carbonization, and then we have a final product, which is actual biochar, which is very rich in nitrogen and phosphor, which could be used as a nutrient, and then it will also bind carbon and actually work as a carbon sink. Biochar can then be used in landscaping and in agriculture, because, as I said, it was rich in nutrients. It collects moisture very well and makes the soil even better for growing than whatever you grow in it. So it can have a very wide use area. And that was more or less the things I wanted to highlight. So thank you for the opportunity, and maybe some questions if needed.
Thank you very much, Aimo. What an important work you have there at Stormossen. But from your presentation, I noted a couple of questions. First, I would like to know what could be your role in carbon neutral Vaasa?
I think the role it can be very big, because without a solution for the classical landfills and segregation of waste, we will not come to any carbon neutral solution. And on top of that, we can also be like a, shall we say, opportunity provider for smaller technologies to develop their solutions, and of course also for the bigger ones, and be a part in a more of a system solution, or a part of it, not just to provide an energy system, but a carbon neutrality solution where waste management and energy topics are solved together.
Okay. Thank you, Aimo. That was very close to the another questions I noted, and that is because Stormossen can be seen as a frontrunner in circular economy, offering a lot of opportunities for companies or individuals sharing your vision. Can you name some areas where there is a need for accelerated business development?
I think actually two steps. One is to take care of that we really get people involved in the segregation part of waste. Because if you, for instance, take an example that if you burn one plastic bag of waste, shall we say at the summer cottage, you can run waste energy 12 days and it will create the similar amount of shall we, impact on the environment if you count the dioxin level. So that's one part. But then, of course, the smaller companies, and the bigger ones as well, they don't realize what kind of fantastic support we could provide for them to try new solutions and new advances and be a part of it. We can maybe not be the front runner, but we are glad to help and assist because we have quite a lot of gas knowledge. So there, I think our role will be in the future.
Thank you, Aimo. So that means that I hope that our audience, there will be many and will pick their phone and call you and start a cooperation with you, because I think we have a big opportunity for our region here. Thank you very much, Aimo. Thank you.
Yeah. Thank you very much for the opportunity.
And our last speaker today is Mr. Juha Ripatti, Head of Business Intelligence at West Energy. He will tell us about decarbonized waste to energy, opportunity for sector coupling. Nice to have you with us here today, Juha.
Thank you so much, and good afternoon, everybody. So my name is Juha Ripatti, and I work at West Energy Limited as Head of Business Intelligence, responsible for the strategic development projects our company is undertaking. And I'm very pleased to be with all of you here at EnergyVaasa Talks today to present our vision of decarbonized waste to energy and how we can connect with the gas sector. So looking at the previous presentations, it looks like our vision corresponds very well, and that's a great starting point for this transformation. First, perhaps, next slide, please. A few words about West Energy. So we are a circular economy company, as Aimo mentioned, operating a waste-to-energy plant in Koivulahti, 10 kilometers from the center of Vaasa. And annually, we refine up to 200,000 tons of source-separated municipal waste into energy and materials with very high efficiency. And we return over 30,000 tons of recycled materials back into circulation every year, ranging from valuable metals such as gold and silver to more bulk items like steel and minerals. As with Stormossen and our 5 other municipal waste management company owners, we help this system working and keeping the wheels of the circular economy rolling and in motion. With the help of another of our partners, Vaasan Sähkö, we ensure that the energy we produce heats and electrifies over 10,000 households in the Vaasa area. And actually last year we produced more than 1/2 of all district heating needed in the region. But nevertheless, I think we will need to turn sector coupling up a notch to answer the challenge of climate change. Next slide, please. As we can see, West Energy is already making the world a cleaner and more sustainable place, but we must be able to do even more. A much-needed paradigm shift is finally happening to curb greenhouse gas emissions and slow down the devastating effects of climate change. And we really want to support all of society in this process of decarbonization. And the technology that will enable this ambition is carbon capture, utilization, and storage. And as you can see, we're certainly not alone in these ambitions. Firstly, global experts such as the IEA see carbon capture as a crucial tool in the fight against climate change. Secondly, our own industry has identified these opportunities, with many European countries, especially around the North Sea, already building up capabilities to capture carbon on an industrial scale. And finally, the work we and our colleagues have done to raise awareness is starting to bring results at home as well. So CCUS technologies are now identified as key solution for emission reductions in the Finnish waste-to-energy sector by the Finnish government as well. So it's important to remember that not only can we reduce carbon emissions to zero thanks to CCUS, but that we can actually go further. as the waste we utilize is made of more than 50% of biogenic materials, not just bio-waste, but other components as well. And as you saw in the last presentation, I think it's important to respect waste hierarchy. But there is still a lot of biogenic carbon in the waste regardless of that. And capturing this carbon brings a huge potential of negative emissions. In other words, removing carbon from circulation and easing the strain on our climate. And on a European level, our sector could achieve up to 100 million tons of such removals every year with the help of this technology. Next slide, please. So the question is not whether or not carbon capture is needed, but rather how it will be implemented in the larger framework of decarbonization. As you can see, West Energy has been decarbonizing its main product, district heating, from the very beginning. By replacing polluting coal and gradually updating our process, we've been able to do more with less, so more heat with less emissions. The specific CO2 released by a kilowatt hour of heat has been more than halved by our efforts. And we plan to go even further. We have the goals of the upcoming Green Deal for the Finnish waste management sector, and we have to reach those. And the research work that we've already carried out with our partners has been very helpful along this way. Removing plastics, fossil plastics, decarbonizing logistics, those kind of issues will support our aims, but carbon capture will be pivotal in reaching the final targets. Our plan is to build a demonstration plant for capturing carbon dioxide by the mid-20s. This pilot will be crucial in testing the technology, but I think it will also be a commercial venture that tests out our business model and our understanding of that. And all of this is needed before we can become truly carbon negative through full-scale capture at the end of the decade. To get there, of course, we need robust economics, we need funding support to develop these solutions, and a stable vision of future regulation. Just to elaborate perhaps on the opportunities of a West Energy-sized carbon sink, we're talking of emission reductions comparable to 1/2 of present consumer vehicle use in Ostrobothnia. So the logical question is, of course, what to do with the captured carbon dioxide. Next slide, please. I must confess that there is something of a challenge here. For negative emissions, one needs to remove carbon from circulation permanently. And globally, we have ample room to store centuries worth of carbon dioxide safely and securely. Sadly, in the Baltic Sea basin, these opportunities are much more limited. Storing captured CO2 geologically in Finland is, in our understanding, out of the question, at least for now. And there's a long queue to the closest storage sites that are just starting to open in the North Sea. Storage, thus, it's both necessary at some point and problematic if we want to get going soon. So the question is what to do. Next slide, please. Furthermore, there's the question of funding this whole thing. So to simplify, a means of value creation must be found for the nearly 200,000 tons we are planning to capture annually in the 2030s, not the 1930s. Storages will certainly be a solution in the long term, but for now there's limited availability, long distances, high prices, and simply a lack of societal demand in the form of incentives. And that means that this option is hard to realize right now. There's, however, another option, and that's called utilization. And here's where we truly arrive in the territory of sector coupling, so the issues that the gentleman before me have expressed. By utilizing the captured CO2 as a feedstock with other chemicals, new synthetic products with added value can be manufactured. So when looking at future energy systems, a clear example comes to mind: methanization, power to gas, in connection with renewable hydrogen. Such products that can be made can also be sold on existing markets, and they will replace fossil fuels and at the same time cover the capture costs, provided, of course, that there is the right kind of regulation in place and the production price remains competitive. So finding added value to society from this whole process is our job as a company, pretty much at the end of the day owned by the citizens of municipalities in Western Finland. And to do this, we need both storage and utilization of CO2. And as I mentioned, West Energy is planning to build a demonstration plant for carbon capture, and in this field, we need partners to achieve this common goal. So sector coupling is the way forward. And I think it's a good way to wrap up by discussing just that. So next slide, please. So how to couple waste to energy with gas? Well, first of all, there's a lot of infrastructure needed for the handling of the first gaseous substance in question, carbon dioxide itself. If it is to be transported anywhere, you need tanks, trucks, pipelines, liquefaction infrastructure, and so on. Shipping solutions probably as well. And as you saw in Aima's presentation, West Energy already supports our owners in increasing the production and also uptake of biogas. And the potential of synthetic biomethane, that's something that will further enhance these activities. To make synthetic methane a reality, we need hydrogen and thus renewable electricity as well. And this necessitates further new couplings. The common product of such cooperation can transform volatile renewable energy into a more stable fuel source for heavy road transports, for example, rural and urban construction machinery, and the marine sector, where electrification alone will not be sufficient for the needs of decarbonization. Carbon capture, utilization, and storage is not just an enabler of decarbonization in the waste to energy sector, but I think it's also an enabler in a much larger industrial framework. And there's significant global demand for these kind of solutions, and the best way to reach those markets, I think, is to test and commercialize these solutions at home, where they can simultaneously help with national climate goals. With the upcoming Green Deal for waste to energy in Finland, as a framework, so to say, these new decarbonized ecosystems can be built to suit, I think, both local and export needs. And just to end this presentation, I must highlight our local Energy Sampo Consortium, as for example Kenneth presented in the beginning, which is really a pioneer of sustainable sector coupling led by many of the most important energy companies in Finland. And we are at the West Energy both delighted and excited to be able to cooperate with Energy Sampo, so that we can build the sector couplings that bring about this energy transformation and decarbonized waste to energy as well. And I think West Energy is committed to staying at the forefront of sustainability, so everyone's welcome to join us there, and let's make this transformation happen. Thank you.
Thank you, Juha, for your presentation. It was very interesting. And we, of course, have some questions for you too. And firstly, beside West Energy's essential role in local waste management, it is a demonstration and a pilot plant. Can this carbon capture solution become a new export product for EnergyVaasa and Renergy clusters?
I think you've hit pretty much the nail on the head here. So these technologies are the kind of carbon handprint that our companies can enable globally, and actually are already doing. So there's, for example, an Ostrobotnian company supplying some of the main process equipment to the nearest Norwegian carbon capture plant at Brevik. But I think it goes beyond that, given that these are always ecosystem efforts with many parts forming the CCUS value chain. So there's quite a lot of different opportunities for companies from the Vaasa region. And when you look at how carbon prices are developing just within the EU, demand might pick up quite quickly. Of course, West Energy is not the technology provider. That's the job of all these other companies. So I think we can develop great things together.
And in that case, locally, thinking about the future opportunities that you already mentioned, what are our strengths and what should we be developing?
Well, I think there are two big issues here. The first one is optimization. So there's still a lot to do with these technologies to extract the kind of efficiency and performance that is needed for them to become economically viable. And I think Finnish engineers are notoriously good at optimizing, so I'm not worried about that. But of course, in our case, we need something that works well with the district heating network and produces a lot of heat. But in different points of globally, the demand may be different. But I think the bigger question is that there needs to be a robust market for technological carbon removal, incentive for negative emissions, market demand for fuels, synthetic fuels, and so on. And this is not just the job of energy companies, but also regulators and politicians. So if there is a framework and a long-term outlook, that's when business models can be formulated, you find demand, supply, so on. That's when investments will begin in earnest, and when CCUS will grow from these pilots into a full-scale industry. So I think that's also a thing, and there we need to use our muscle, so to say, to speak in a common language together. The technologies themselves will work, I'm sure of that.
We agree with you totally, and thank you for being with us today.
Thank you.
Thank you very much, Juha. It's time to make a short conclusion about this event today. And once again, many thanks to our excellent speakers today. And the YouTube channel is still available for our audience for further dialogue with our speakers. As we have seen today, EnergyVaasa is actively developing solutions for decarbonization of the world. And what is more, Vaasa region is one of the frontrunners in using the cutting-edge technology urgently needed in the nearest future. We thank our audience. We hope that you have found this information useful, and
don't forget to join Energy Week 2022 and Vaasa Gas Exchange event in March next year.
See you.
See you.